The renowned physicist and Nobel laureate Roger Penrose has made a bold claim by suggesting that the black hole of an early universe was responsible for the Big Bang and the birth of our present universe. According to Penrose, our Big Bang was the result of an earlier eon that compressed into a flattened infinity, implying that our eon began with the Big Bang and will end in an exponential expansion. Before us, there was another eon, and after us, there will be another, and so on, forming an infinite Big Bang cycle. This theory posits that the universe undergoes constant imaging and expansion until it reaches a point where there is no more energy. Then, somehow, another Big Bang arises from that state. Moreover, recent discoveries made by the James Webb Space Telescope support this argument. Stay with us because we are going to delve into the details of these recent discoveries made by the James Webb Space Telescope and Roger Penrose's bold statement on the truth of the universe. The remote future manifests itself as we go about our daily lives. The vastness of space often stirs our imagination, and when observing the night sky, we sometimes come across objects that are strangely familiar to us, raising a host of questions in our minds about the origin of nature. Thanks to scientific and technological advances, we have come to understand that these celestial wonders are composed of the same fundamentals that make up our own existence. We find ourselves connected to the elements of the cosmos. With the advent of powerful telescopes such as the James Webb Space Telescope, we have acquired the ability to explore more distant corners of the universe. Each observation takes us on a journey through time, revealing the secrets of the early stages of our universe. According to our current understanding of the cosmos, this was a time of young stars and galaxies, a period of cosmic birth. Our standard model presents us a vivid representation of the early universe, showing us the evolution of galaxies and stars over time. This model is based on careful observations with powerful telescopes, as well as our own current knowledge of the laws of physics. However, recent revelations from the James Webb Space Telescope have challenged our established model. The intriguing concept posits that black holes existing in an earlier universe, which already possessed considerable mass, may have had an influence on the expansion of our present universe. Observations of radiating spots in the cosmic microwave background support this idea, strengthening the notion of a cyclic process. This proposed model may seem far-fetched, but it somehow makes sense with the notion of the Big Bang and the remote future of an earlier eon. Instead of conceiving of the universe as a single event, with the Big Bang marking the beginning and the remote future representing the end, Roger Penrose posited that this is just one eon, one stage in a possibly infinite succession of eons following one after another. Were these black holes from a previous era really responsible for driving the expansion of our universe after the cataclysm event known as the Big Bang? Or are there other mechanisms at play, hidden by the limitations of our current understanding? The events that took place after the Big Bang are intricate and complex, exceeding the explanatory capacity of existing theories. Our current understanding is insufficient to elucidate the enigmatic behavior exhibited by these earlier galaxies. In light of these astonishing revelations, perhaps it is time to consider alternative theories of creation to help us unravel the mysteries of the early universe. The limitations of our current model governing our understanding of the universe become evident in the face of these cosmic enigmas. It may be necessary to consider new perspectives such as the existence of a universe of black holes or a multiverse that can shed light on our cosmic origins. In a recent study conducted by a team of German and Georgian researchers, an intriguing idea has been put forward. Advanced civilizations could be using black holes as quantum computers. This study, conducted by Gia De Wally, a theoretical physicist at the Max Planck Institute of Ludwig Maximilian University in Munich, and Sarah Osmanov, professor at physics at the Free University of Tbilisi and a researcher at the Georgian Astrophysical Observatory in Harad, is currently under review for publication in an international astrobiology journal. This research suggests that black holes could be the key to understanding why we have not detected extraterrestrial activity in the cosmos. Traditionally, the research for extraterrestrial intelligence has focused on looking for radio signals from distant star systems. However, the researchers argued that this approach may be overlooking other possible technological signals. So they suggest broadening the research to include a wider range of phenomena, such as neutrino signals, quantum communications, and gravitational waves. Quantum computing offers exponentially faster processing speeds and greater security compared to traditional digital computing. Given the rapid advancement of technology, it is reasonable to assume that advanced civilizations would adopt this technology on a much larger scale. Black holes, with their ability to store and process quantum information, would be ideal for meeting the computational needs of these civilizations. This idea, based on the work of physicist Roger Penrose, who theorized that black holes could provide an unlimited source of energy by extracting rotational energy from the ergosphere. The ergosphere is a region located just outside the event horizon of a black hole, where matter falls into a rapidly spinning disk and emits enormous amounts of radiation. It is interesting to note that our galaxy hosts a supermassive black hole of approximately 4 million solar masses. In addition, our galaxy, the Milky Way, is expected to collide in the future with the Andromeda Galaxy. Although it is uncertain when this will occur, it is an event that will happen sometime in the future. Black holes are likely to spiral into each other, and some researchers have suggested that harnessing this energy could be the ultimate energy source for an advanced extraterrestrial civilization. In their study, Duwali and Osmanov proposed that black holes could also be used as the ultimate source of computation to optimize computational performance. The researchers argue that advanced civilizations would create numerous microscopic black holes, which would be more energetic than natural black holes. These artificial black holes would emit high-energy radiation known as Hawking radiation, which could serve as potential technological signature. It is theorized that this reaction is emitted just outside the event horizon of a black hole due to quantum effects. This radiation decreases the mass and rotation energy of the black hole, leading to its eventual evaporation. The emitted radiation would be composed of various subatomic particles, including neutrinos, which are highly penetrating and therefore excellent messengers. The researchers suggest that advanced extraterrestrial civilizations could produce high-energy neutrinos using Hawking radiation from micro black holes or through the collision process of particles used in the manufacture of advanced technologies. What if you're not alone in the universe? Not just in terms of existence of extraterrestrial life, but in the vastness of multiple universes. What if there's evidence to suggest the presence of another Big Bang lurking at the edges of our known cosmos? The latest images from the James Webb Space Telescope have raised questions and challenged the established understanding of our cosmology. Could we be on the verge of one of the human's greatest discoveries? The existence of another universe? Gravity stands out as a fundamental building block in the evolution of the universe. It is one of the 4 basic forces of space, according to Albert Einstein's theory of general relativity. This not only explains the expansion of the universe, but also the formation of large-scale cosmic structures. However, there is much more at play. Scientists have identified forms of energy and matter, such as dark energy, dark matter, ordinary matter, neutrinos, and photons. These elements are essential but largely unknown to current science. The existence of dark energy and dark matter is based on computational assumptions and limited observations. Although they offer a plausible explanation, their existence has not yet been demonstrated with certainty. This raises questions about the validity of the standard model of the Big Bang and the development of galaxies. According to current models, our cosmos originated approximately 13.8 billion years ago at the Big Bang. However, the structures observed by the James Webb Telescope do not completely agree with the predictions of these models. These discrepancies could indicate that the rules governing the formation of matter and the first stars are different from what was known in physics until now. Imagine following a path you thought you knew, only to have it fork unexpectedly, taking you to a place that is partly familiar, but also so changed that it's difficult to understand within the parameters of your perception. The beginnings of our universe from the Dark Ages just after the Big Bang are full of mystery. Theories of cosmic inflation and patterns in the cosmic background noise indicate an incredible uniformity at the beginning of the universe. The complexity of how the first stars, planets, galaxies, and black holes arose is puzzling. Attempting to understand these early moments of the universe by piecing together observations and known quantities into a coherent equation has been the goal of the Big Bang theory. However, the appearance of early galaxies that defy this model suggests that perhaps the universe is older than estimated, or the fundamental rules of physics were different at the time. Thus, we are at a pivotal moment, questioning our fundamental assumptions about the universe and the reality we inhabit. The James Webb Telescope had shed light on ancient galaxies, offering an unprecedented look at early stages of our universe. Before launching the James Webb Telescope into space, we knew that a galaxy existed approximately 13.8 billion years after the Big Bang, a finding consistent with the Standard Model. However, this discovery, previously made by the Hubble telescope, raised questions. Galaxies do not emerge out of nowhere. An extended period, possibly millions of billions of years, is needed for their formation. How did these first galaxies form? Were individual stars grouped together by gravity, or were they already present within the structures that later became galaxies? Before James Webb, scientists relied mainly on the cosmic background radiation, considered a remnant of the Big Bang, to map the early cosmos. But now, thanks to the JWST, we can observe light signals from that early epoch, represented by more than 100 galaxies that existed in the 400 million years of the universe. These galaxies are called candidates because it is not yet fully confirmed whether their detected light is actually correspond to the galaxies. Although the most advanced ground-based telescopes are being used to confirm the JWST findings, some preliminary results have shown the presence of light emitted by galaxies between 13.4 and 13.6 billion years old. One example is GN-Z11, confirmed with a redshift value of 11, representing an age of 13.6 billion years. In addition, candidates with 20 Z values have been detected, which could break the cosmic distance record within the 12 months. However, some discrepancies have arisen. A galaxy initially classified with a high Z value, suggesting an age of 13.6 billion years, in a second measurement turned out to have value of 4.9 Z. This ironic phenomenon led to the nickname Schrodinger's galaxy, a reference to Schrodinger's cat of quantum theory, which can be in multiple states simultaneously. These revelations challenged previous assumptions about redshift and raised crucial questions at the limits of our understanding of physics. The first galaxies shown by the telescope, along with the uncertainty in their measurements, exhibit puzzling properties similar to Schrodinger's galaxy. In addition, the discovery of ancient star-rich galaxies raises another conundrum. These galaxies were thought to limit the inflow of gas, but they appeared to have grown faster than expected, defying expectations about the speed of their formation. The object we are observing could belong to a different universe than the one we know. So far, our understanding has been based mainly on classical experimental physics. However, as we enter the world of quantum physics, or the more daring theories of other branches, we find more fascinating explanations for recent observations. In the framework of quantum physics, it is possible that galaxies like GN-Z11 are no longer within our universe, but are part of another universe, perhaps starting beyond the limits of the cosmos we have explored, or even partially overlapping it. In simple terms, this suggests that we might find limits or differences in the physical regularities we know. If the compatibility of our physical law stops, it is likely that we are facing another universe. This other universe could have arisen from a completely different Big Bang at a different time than our own origin. The notion of a multiverse, a vast panorama of alternative realities that coexist beyond our current understanding, opens the door to an infinite range of possibilities. Within this concept, the idea of other dimensions, spaces, or universes becomes a fascinating subject of speculation for scientists, philosophers, and amateurs alike. As we consider the vastness of the multiverse, we are faced with the intriguing possibility that our current observations may be only a small window into a much larger and more complex reality. The phenomena we witness may be only a fraction of what is actually occurring in the vast fabric of the cosmos. In our scientific investigations and explorations of the universe, we may be detecting hints, subtle clues to the existence of other dimensions or parallel universes, perhaps in the gravitational anomaly at the edge of our galaxy, or in the mysterious cosmic patterns that don't quite fit our current theories. There are signs of interconnected, alternative realities in an expansive multiverse. This idea challenges our conventional understanding of the universe and prompts us to rethink traditional notions of space, time, and reality. What impact would confirmation of the existence of another universe have on our own lives and our understanding of our place in the cosmos? How might we interact with these alternative realities, if ever? The explorations of the multiverse not only opens up new frontiers in the field of theoretical physics, but also invite deep reflections of the nature of reality and our perception of it. Ultimately, as we continue to explore the frontiers of human knowledge, the multiverse stands as a humbling reminder of the infinite richness and complexity of the universe we inhabit. NASA has announced a disturbing new discovery that could have major implications for all the world's religions. Reports suggest that NASA has found a celestial wonder that has baffled scientists and astronomers for decades. This dedicated team has been exploring the mysteries of the universe and has finally revealed a shocking surprise. What does this discovery imply about the nature of existence itself? Join us as we investigate the enigmatic City of God leaked by NASA. A fascinating photo has surfaced from NASA's archives, generating speculation and questions about its meaning for humanity and religion. On December 26, 1994, NASA scientists were stunned to observe images captured by the Hubble Space Telescope, a white city suspended in the cosmic void. This revelation has baffled the NASA team, raising questions about whether the world has prepared to understand the significance before it was revealed to the public. Although Hubble telescope images are usually confidential, in this case, they mysteriously became accessible to the public within minutes, spreading across the internet and capturing the imaginations of millions around the world. However, the US government quickly intervened by classifying the images to control public concern and maintain control over the dissemination of information. Despite this effort, the images were already in the public domain, circulating among a curious audience eager to decipher the hidden secrets. During the chaos, a photographer at Ellington Airfield managed to capture snapshots of the image, revealing a stunning galactic landscape filled with columnar structures and formations that resembled architecture. At a critical moment, University of Florida Professor Ken Wilson pored over the photograph taken by the Hubble Space Telescope, using a powerful handheld magnifying glass to examine the details. Wilson focused on a peculiar patch of hazel that defied conventional explanations. Through his meticulous investigation, it became clear that this haze anomaly was unique and had an unusual shape, which generated uncertainty among the scientific community. Although NASA experts quickly ruled out the possibility of a transmission or lens diffraction error, confirming that the image itself was perfectly fine and that the telescope was in perfect condition, puzzlement persisted. In response to this situation, NASA representatives called an urgent meeting to try to capture the image again, this time with greater precision. The Hubble Space Telescope was reprogrammed to maximize its resolution, and its lenses were meticulously aligned to focus on the mysterious section of the cosmos. As the world held its breath, scientists awaited the result of the mission, watching as the telescope captured the scene unfolding in depths of space. As the image materialized on the screen, a hush fell over the laboratory, interrupted only by the collective gasp of astonishment from the assembled researchers. The haze had transformed into a glowing structure in the center, bearing an uncanny resemblance to a futuristic city stretching across the vast expanse of the cosmos. The structure defied all logic and sense, becoming one of the most notorious mysteries in the universe. The project took on a life on its own on the internet and became known as the City of God, even within scientific circles. While some believe it could be a heavenly paradise or a realm inhabited by souls, these ideas sound more like myths than serious scientific research. Despite the disbelief of many within NASA, researchers delved deeper into the images captured by the Hubble Space Telescope and made a fascinating discovery. The city was not simply floating in space, but showed a dynamic motion synchronized with the galaxies, following the fundamental principles of the theory of the Big Bang and aligning with the laws governing the expansion and evolution of the universe. This finding puzzled scientists, who began to investigate the peculiar motion of the city. Using advanced computer models, they discovered a curious phenomenon contrary to conventional beliefs. It appeared that the universe was not being observed by the city, but that the Earth was moving away from it. Could this mean that there was a potential central nexus within the cosmos? The researchers traced how galaxies seemed to migrate away from this fuzzy focal point with each new revelation. The City of God unfolded as a deep enigma similar to a labyrinth of unrevealing cosmic mysteries. Each piece of the puzzle offered new insights into the intricate workings of the universe, challenging humanity to rethink beyond the confines of conventional knowledge and to contemplate the wonders that lie beyond our world. Numerous claims have surfaced about NASA's attempts to keep a remarkable image secret from public scrutiny. There is speculation about the motives behind this alleged cover-up, especially the reason for withholding such a significant cosmic revelation. The decision to withhold what some consider to be one of the most important scientific data research sets ever recorded has aroused curiosity, but many doubts persist about the reasons cited, particularly the fear of provoking global panic. It is puzzling that the governments would choose to make such a decision given that the information is leaked anyway after meticulous examination of the photographs. This analysis has revealed intricate details that defy conventional explanations rooted in natural science. Dome-like and tower-like structures have been identified, and even what appears to be a watchtower, suggesting the presence of a sprawling galactic city characterized by futuristic geography. In addition, celestial beings have been sighted within the image, reminiscent of angels initially mistaken for a star cluster due to their vibrant hues. However, further analysis revealed that these luminous entities have an appearance similar to that of a living organism. NASA sources indicate sightings of a group of angels in flight near the star cluster NGC 3532, initially dismissed as an abnormal transmission due to a malfunction of the Hubble telescope. However, clearer images have captured angelic beings approximately 15 meters tall, adorned with wings and ethereal halos, shrouded in mist-like auras. This discovery raises the question of whether these images could be the first recorded visual evidence of angels. A space engineer reported that the beings observed in Hubble images were approximately 15 feet tall, with a wingspan comparable to that of airplanes. Their faces appeared calm and friendly, radiating a sense of joy as they posed for the celestial photograph. Their expressions conveyed a sense of shared delight, as if they were intriguingly imparting a revelation to the cosmos. Accounts of angelic encounters are not limited to this event. A scientist who defected from Russia in 1985 revealed that Soviet cosmonauts had sighted luminous entities during a mission years earlier. According to their claims, such celestial beings could be abundant in the cosmos, waiting to be discovered through continued exploration. The prospect of revealing evidence for the existence of angels is on the horizon with the ongoing operation of the telescope, which will shed more light on this enigmatic phenomena. The revelation of the angelic images on the day after Christmas in 1994 adds a layer of intrigue to the narrative. The timing of this revelation is something that raises questions too. Could there be an underlying motive behind the disclosure of this celestial spectacle during a period traditionally associated with themes of spiritual contemplation? If you liked the video, don't forget to like, subscribe, share it, and turn on the notification bell. Thank you so much for watching.